Good morning, everyone. Thanks for joining us today. I hope you're doing well. My name's Katie and I'm the course coordinator at the National Self-Build and Renovation Centre. I would like to welcome you all today to our 11 a.m. session, which is Key to Passivhaus, the PHPP energy model, and this will be presented by Jay Cottrell. So just before we begin, I'd like to show you a couple of functions on Zoom that you can use in order to interact with us today. If you joined us earlier for the introduction with Chris, Harvey will have also shown you these functions. So we've just got a question and answer session. So if you'd like to put forward any questions to Jay, she'll be able to answer a few of these at the end for you. And for any other comments or queries, you can use the chat function on the right-hand side. So we do have a question time session today at 3 p.m. So if we don't have time to answer any of your questions during this session with Jay, then please feel free to put these forward at the session later on. And just to remind you all that we are recording these sessions and you will receive the link to rewatch these webinars if you wish. You will receive these shortly via email. We will get the link sent out to you promptly. And just before we hand over to Jay, we've got a quick poll for you. So I'm just going to launch this, and it's just so that Jay can see who she's presenting to today. So I've just launched this and it should appear on your screen. So I can see a few of you are starting to vote, so that's brilliant. Just give that a minute and wait for all the results to come in, and then I will publish the results so you can all see. Just a few more people to go. We've got about 132 attendees in this session, which is fantastic. Okay, so I'm just going to share the results with you all. Okay, so about 60% of people have answered, I'm an individual thinking of building an energy efficient house. It's quite interesting. Okay, so just minimize the poll now and I will hand over to Jay. We'll get your camera on. There you are. Hi, Jay.
Hello.
All right, so without further ado, I will hand over and I hope you will enjoy the session. Thank you very much.
Great, thank you very much. Katie, I'm going to now try and share my screen. Hopefully we can carry on. So I'm not quite going into full area. So I think that you are seeing all of that, hopefully. And I am an architect and I've gone slightly AWOL in that I actually now provide a low carbon or for buildings for net zero carbon housing if people want to go that far using Passivhaus principles, and that's in order to get the operational carbon really low. And we also are interested in low embodied carbon and also in using non-carbon fuel sources or low carbon fuel sources. So we're interested in those three things, and we use Passivhaus principles in order to get the operational carbon down, and we're using the PHPP energy model in order to check that and to design that. So just trying to get it going to the next page. So here we are talking about sustainable housing, and the three big bits of what I've just spoken about is the Passivhaus bit, which is the energy efficiency bit, which is the operational carbon, the blue, and then there's natural and minimum processing, which is how you actually build a house, and then there's the low carbon fuel source. And the compliancy and the quality assurance for the big blue bit is all done through the PHPP energy model. And when you're looking at operational carbon, you're looking at that big yellow bit. So that's all the operational energy that you're using in a house. And basically Passivhaus focuses on the big element of it, which is the space heating, which is 60% of an average house's energy is in the space heating. And if you're thinking about building a new house to building regulations, then you'd be on average achieving something like 86 units of energy for every square metre of your house in a year, whereas the sort of Passivhaus minimum, which is 15, is what you're allowed. So it's a 70 to 90% reduction when you're building to this sort of standard. So it really is something quite significant. I'm sure Chris will have talked some of these points to you in the earlier session if you were in it. And it's an integrated approach. And by that I mean you have to do various things. So you put in various things and then you get various things out. And the three main things that you put in are you put in the thermal shell, and then any holes that you make in the thermal shell, you make sure that what you fill it in with the glazing or doors is done to a very good standard. And then you have a ventilation solution at the end. And all of those three things are you can't get one and throw it out and think you're going to get there. You need all three things to come together. And then at the end of when you've done that process, you're obviously getting your low carbon emissions, which I'm particularly interested in, but there's all sorts of other things that you get out as well, all sorts of other bonuses that come with it. So when you come to the PHPP, you have three targets that you can aim at. It used to be just one, the classic. Now there's plus and premium. Premium is very, very extensive. I've tried to do it once and you needed a huge amount of renewable energy. The middle one, plus, is basically where net zero carbon sits. So that's where you're doing the fabric first ideas of Passivhaus, getting your house shell correct, getting your windows correct, getting the ventilation system, but then you're adding some renewable generation on site and you're getting it to a place where you're generating as much as you're using through an average year. And we try to model to the plus standard, even if the client isn't wanting to go there, so they know at least what they need to do to get there and they can perhaps plan for it in the future. So the sort of targets that the PHPP modelling software spits out are the space heating, which we talked about, that 15 figure, but also it looks at the energy of the house, all the energy, so for hot water as well, and your lighting and so forth. And the critical thing that we use PHPP mostly for is to calculate the overheating frequency, because once you go to these low carbon energy efficient houses, the risk is not that you'll be too cold, but that you'll be too hot. And the PHPP is a way of looking at that and designing that out. And how it comes is it comes in the format of a disk. It's not actually very expensive, PHPP. It's very easy to buy. And it comes as an Excel spreadsheet, basically lots and lots of pages, which I'm going to show you. And it has 6 dimensions to determine shading. That's because, as I said, overheating is quite difficult. And so it can be a bit time consuming, a bit confusing, but it is accurate. It's known to be accurate. So if you're not used to using it or you're not using it regularly, it's not very user friendly, I have to say. But it's the way that every design is checked by an external certifier if you're going to certify to Passivhaus. So we will do a PHPP, but if it's going to be certified, it will always be being checked by someone who's external to us. The other option you can have if you're an architect, there are a few architects listening, is that you can go for design PH. And that's a little bit more expensive. And basically it's a 3D design tool and it plugs into SketchUp. Hopefully quite a few of you are familiar with SketchUp. And it's much more user-friendly, less likely to make mistakes, and you can do really good shading analysis because it uses the 3D geometry to analyze it. So I would recommend that to people who want to have a go and who are never going to really become highly familiar with using PHPP. They're going to be using somebody else to do that. So when you're starting to use PHPP, you're looking at the planning stage. So you want to design either with PH Design or the full PHPP before planning. So we do the full PHPP before planning, and you sort of got drawings a bit like this. So this is a house Compton that we're looking at here, and from here we can start to insert all the necessary data into the PHPP model. And I'm going to show you now, this is what the spreadsheet looks like when you open it up. There's lots and lots of tabs basically along the bottom, and I'm going to go through the main tabs with you just to show you the sort of detail that goes in when the PHPP is being done. The verification page at the beginning, which you'll see in a minute, is just telling you where you are with these headline figures. But the first real tab is the climate, and there's lots of data preloaded in, and basically all you're doing is choosing where your site is, and there's lots of preloaded information. And this one, the nearest climate data set was Efford. I just pick this on a drop-down menu and it populates, and that's it. That's all you're doing. And you're also adding your altitude. Strangely, altitude is very important to make sure you get it accurate for your particular site. Interesting, because you can then take your house and you can fly it round, of course, in the PHPP, which I quite enjoy. So you could take, this one is in, this particular house was in the New Forest, edge of the New Forest, but I could change the climate data. I could fly it to a site in Scotland and see how it performs there. And there are big differences according to altitude and where you are, even within the UK. And then you have to try and start thinking about how you're going to build it. Passivhaus U values, you have to be under 0.15. That's the thermal efficiency of your walls, your roofs and your floors. And usually with our system, PH15, we're looking around getting to 0.1 to 0.13 to get past the line for Passivhaus. So you're deciding on all your assemblies, and then you have to calculate the U value of each of those elements. You can, at the design stage, just assign notional U values, so you can sort of trick it, or just say I want it to be about this, or you could start to see what do I need to get to for these elements in order to pass the line. I just make this point here because obviously we're choosing timber, and that's because of the embodied carbon. This has got nothing to do with PHPP or Passivhaus, but you can just see according to how you choose to build. Passivhaus is the way you build it. It doesn't have anything to say about how you're building it. You just need to build it to the principles. But you can see that there's 4 times more carbon in traditional masonry when you're building to this sort of standard, 3 times in SIPs with oil-based insulation compared to a timber frame. And that's why we go timber frame, because of the embodied carbon. So here's three different timber frame assemblies, just to give you an idea what we mean. So this is the way I build, with an I-joist and an airtight board and wood fibre. This is called a Larson truss, and here's a typical SIPS panel. So you have to choose your assemblies, and that's for your roof as well and for your floor. Now we come to the actual verification page. There's a few interesting things on the verification page, just to show you how detailed they are. There's something here called the specific capacity, which is which one you've chosen. So masonry's heavy weight, our system is deemed medium weight, and that SIPS solution would be deemed lightweight. And you put a figure in here to reflect the thermal mass of your chosen construction method. And then it makes a few assumptions as well, like it assumes how many people are going to be in your house, depending on how big it is when you start to fill it out. And you might find that you're going to have more or less people than that. And there's a little button here that you can use to determine how many people are in the house. If you're doing social housing as an architect, I would suggest you might want to check it for having a higher occupancy level and see how it performs. So it lets you have a little play with those sorts of ideas as well. And then down here you choose which of these 3 standards you're going for. Are you going for a classic? Here we're looking to see at the plus standard here, have we passed, and here are the headline figures, and here are whether we fulfilled them or not. And we go to the next sheet now, and this is the U values, and you can see you label each of your assemblies and you put in what you, so this is a ground floor slab. We've got a concrete slab here. This is called the thermal conductivity. These are all, every material in the universe has a thermal conductivity. So you find out what that number is and you put it in there. And you say how much thickness you have of each of these things. I've got 175 of Celotex, and then it calculates the U value out. And generally all the yellow boxes are where you put things in, and the green boxes is where the PHPP calculates it. And the lower the U value, the better it is. It gets a little bit complicated, more complicated sometimes. This is our wall where we're saying, yes, there's lots of insulation here, but there's actually some timber in this wall. This is a timber frame. You can see there's lots of timber in this wall. And I'm saying here that I've got flanges of timber, bits of timber. 15% of that insulation is actually bits of timber, and I've got some webs in here for my eye joists, and 3%, and that adjusts the U value down to take account of the fact that I've got all this timber in my wall. And that's because, you know, this is what you can get when you start doing timber, poorly designed timber, lots and lots of timber, what's called the timber fraction, and that will severely affect your U value at the end. And Passivhaus is very rigorous about this sort of thing. It won't let you just put in a point U value. It wants to know actually how have you designed this house, and we have to show the certifier to justify these figures so that we're not fooling anybody. And here's another one where there's a wall very badly done. Someone actually thinks that's good, but you know, when you think about how much of this wall has now been stuffed full of poorly designed timber structure, it's really going to affect your U values. Now we start to go on to actually measuring the areas, so all your walls, your floors, your roofs and your glazing areas, and you put them into a sheet. I'm just going to show you actually how you measure, just so you understand very briefly. This is getting a little bit technical now, but you take the whole height of the insulated element right from the top of it on the outside edge right to the bottom, and here's a floor with a concrete floor with some insulation, and you go right to the outside edge of the insulation. So actually you end up slightly over calculating the areas. And so where the difficulties always are is where elements join, and this is where we get thermal bridges, which the PHPP is very thorough in covering, that means that if you do a bad detail where this joins here, you might have, I've said over a house, you might have 30 meters of this poor detail that's really leaking a lot of energy. And if you have a good detail or a poor detail, you really need to prove it by doing a little model. And this one happens to be a very good detail here, and it comes out with a negative psi value, which is very good. And the reason you can get a negative psi value is that you're over egging your areas when you're doing this. That area there is being measured twice. So if you do this little join in the middle very well, you can end up with a negative psi value and a little bit of benefit there. So you're putting in your walls here. Here's one here. This is a south wall. So I've got a south wall here, and I've got one of them, and I'm putting in an area. I've measured how big it is, and I've assigned which of my assemblies from that first sheet. So this is a wall eye joist. So I've already worked that in. So it puts all that data in, and I also put in what its deviation from north, so it knows how big the wall is and what its orientation south, north, east and west is, and how it's built. And then I go on to my windows, and I'm not going to talk too much about this slide other than say that, you know, with our uplift from building regs to Passivhaus, we normally think ours is around the 5% mark, and half of that will be the windows, and that's because they're so important. And there's lots of things going on with them. They're not at all like just a standard UK window. So there's the air tightness around, you know, there's these 3 gaskets, and also the glass that goes in it. There's all sorts of things you can do with the glass, letting more sun in, letting less sun in, and all that information is going in to the PHPP. So we're on the next tab here. I'll just talk a little bit about, we've done U values and areas. This ground one is pre-filled in by the Passivhaus Institute. We never really mess with it. I think you had some strange ground conditions, you might have to. The components is just where there's preloaded lots of components. So lots of windows and glazing things and ventilation systems are preloaded into this area. And then you can pick them out when you put your windows sheet in. So here, this will have been picked out from a list in the components, and this window will have been picked out from the components. And we actually have a pre-filled out PHPP where the windows and the glazing elements that we use in our system are already all listed in there, and you literally just press a button here and you have a drop down menu and you click and up it comes, and then it starts to populate all the data in here. So all I actually need to do is number my window, and I need to give it its opening, and I need to tell it which of the walls that I have put in the area sheet, where it belongs. Then it knows the size of the window, it knows which wall it's in, it knows which glazing, what sort of glazing it has in it, and it knows which frame, which window itself, the frame of the window it is, and then it will calculate all the rest of it. And this is just this is a little bit of a confusing slide, perhaps, but I'm just showing this as a window sitting in a wall, and it's it's an okay installation detail, and there's a psi value for that. This has been modelled, and it's 0.029. And I only say this because this one is much better, 0.019. And the reason is there's just a few tweaks been made. It's been pushed a little bit back in the window, in the wall. This is more to the edge of the wall, and the metal cladding on the outside has been cut back on this window, and it's not been cut back on that window. And none of these have got anything to do with price. This is just to do with good design, and that's why, you know, with us, with our system, we're always tweaking it, because actually good performance doesn't necessarily mean money. Sometimes it just needs thought and an understanding of what you're doing. So I want to just talk to you now about the windows in terms of overheating and why it's a problem. This is a typical low energy house. This is all the losses in the house that you get through the roof and the windows. And then on this side this is the gains that you have. So you put a little bit of heating in the house through a heating system of some sort, but you get more than half of your energy in an energy efficient house through the sun and through your internal gains. That's through you, your lights and your appliances and so forth. And that's why if this gets out of kilter, you soon begin to have problems with being too hot. And that's why low energy houses are so sensitive. And that's why there's a tab especially just for shading. And this is actually the tab that we spend most time on. Basically it's preloaded now with all my windows and doors, and then there's various things to do with shading that I can add in here. So this is things like trees, the horizon. If there's trees or other buildings or something, I put some figures in here. And here it's just about the reveals of the window, how far the window is set or door is set into the wall. And this is to do if there's any overhang or shading device on the wall. And then this is if I'm using any external blinds to shade. So there's all sorts of things I can do, plus the glass itself, which I just mentioned, the quality of the glass, or what's called the G value of the glass, I can change in my windows. That will change how much sun is allowed through the window or not. So there's lots of different things that you can do to tweak your overheating risk. And then the final thing to do with overheating and windows is, so we've gone through loads and loads of these tabs now actually, but there's one of these tabs that sometimes gets missed. It's called summer vent. And this is just showing you that we need to night ventilate in these sorts of houses. And it's saying that on very, very hot days, I need to be able to open some windows. And so what I've got here is I've got two windows that I'm choosing to open just in tilt position. And I'm choosing some higher level windows for them to cross ventilate to. And this calculates how much ventilation I'm getting. We will choose windows always in our houses, what are going to be the night ventilation windows. And we'll discuss those with the client. So if you're thinking of building a house, 60% of you are thinking of building a house, you've got to think which am I going to have of these windows for my night cooling on very hot summer evenings. And then we'll choose them, and then we'll give the client the choice of perhaps adding fly screens to those windows. And it's really important, if you were to take the quantity out, if I took that out and just put naught in there and naught in there, and I went back to my verification page, I'd see how significant having those is to the hot summer days and nights, and how important it is to have a night cooling strategy. And therefore user behaviour is actually quite important in an energy efficient house. And if you didn't do that behaviour, you would be much more uncomfortable in that house for 2, 3, 4 weeks possibly of the year. And these are the sort of shading devices you might be using. So just overhangs, we've got overhangs there. We've got an actual shading device that's being built onto a house here. Here we've got a veranda being used to provide some shading. And then you've also got things like this. We have the option in our windows that we put in our system for external blinds that come attached to the windows, and they get built in, and then you can see it down. And when it's up, it's hidden in the wall. So when that is up, you wouldn't know that it was there. And they're electrically operated, and they're quite a good solution for windows where you might have a problem. Now, the reason I'm going on and on about this with the PHBP is because we have a warming climate, and we stress test our houses, and we find that maybe the overheating percentage could treble in the lifetime of that home. So let's say by 2050 or 2060, you might find your house, which was designed to overheat, maybe the percentage was 8%. It might be a quarter of the year your house was too warm. So the Passivhaus standard allows you 10% of the year for your house to be over 25 degrees. Well, that's far too much. The Passivhaus Trust, Chris might have mentioned this, I don't know, says that 5% should be the maximum. And we try to get under 2% because of this fact that it's not a static thing. And we know that we're going to be having warmer and warmer summers as we move forward. The final thing is MVHR, the ventilation system. So you have to put a Passivhaus certified unit. It's the only thing that must be certified in a Passivhaus. And you're basically supplying fresh air into the house, into all your living spaces, and taking it out of your wet, smelly spaces. And you're basically choosing to control your ventilation rather than having uncontrolled ventilation, which is what we live with at the moment in the UK. And for every unit of energy that unit is using, typically you will be conserving 16 units. So it's a very, very efficient way of providing your ventilation. And here's some pictures just to show you, you need to provide some space. This is a big house, but it's just to show you how significant the space you might need for a ventilation system. This is one sort of a tree supply of the ducts. Here's one that we do. We do a radial system. So each house would have 1 or 2 of these ducts going to it. There's a couple of distribution boxes, one for the supply, one for the extract. Here's the main unit. So there's a lot of these ducts flying around the house to supply your fresh air. And there's a few things that are significant about it that the PHPP is interested in. The length of the ducts from the unit to the outside is one of them, and how well insulated they are. So when you come to the sheet, the tab, now we're moving on to one of our last tabs that I'm going to talk about. You can see that you have to put the length of the outdoor air duct, and you have to put in what the size of it is and how much insulation is on it. And you'll be surprised how much that affects the effective efficiency of your unit. So not too complicated to fill in, but very key to the overall performance. So all the elements are important, all your assemblies, your glazing and the MVHR, and it is essential to have someone who's familiar with PHPP or who's going to take quite a bit of time making sure it's right. And it does help to use a known system. So once it's all loaded into your PHP, then you can have a bit of fun, because none of this so far has been fun, really. It's just been a bit of a task of number crunching. But once you put it in, you can start to play with it. And that really is fun. You can add insulation depth, you can amend U values up and down, you can change the materials, you can swap windows and doors, you can take them in and out, you can change their sizes, you can change the glass spec, and you can add shading, and you can change your MVH. All these things you can do in a twinkle of an eye, and you can see. And here is an example on this house where I worked out on this that these 2 sliders at the end on the west elevation, where the sun is low in the sky, were causing a lot of the overheating. So they had lots of other sliders actually on this house at the front. So we agreed with the client to actually have fixed glazed units. And what's very difficult is when the sun is low to shade this bottom bit of a door, this glass at the bottom. So we just raised this up and we made it into a window seat on these 2. And that saved the client a lot of money, because these are about 4 times the cost, 4 or 5 times the cost of this. It was a nice feature. They didn't really need the sliders there, and it really, really cut their overheating down. So this is the benefit of PHPP, how it can really inform the design and help you to get a really good outcome. So here we have finally the verification page. On this particular house, you can see it was a very efficient shape, very low heating demand, much lower than Passivhaus. In fact, you can see we've designed with all those principles that the frequency of overheating is very low, and pressurization test on ours system is on average 0.3. Passivhaus requires you to be lower than 0.6. So on average, we achieve about 0.3. So using a known system, you should be down to about that sort of level. And you can see here that we're on the Passivhaus Plus. So did it become a Passivhaus Plus? No, it became a Passivhaus Classic. Why was that? Well, that's because it actually has a gas boiler in it. So I want to just address that a little bit, because that's interesting. So you've done your passive house, but how you then heat it affects whether you're classic or plus. But I hope I've demonstrated, I've just entitled this slide Design Tool and Quality Assurance. I hope you can see that it is a design tool, which something like SAP is not. It's very unique in that way, but it also is a quality assurance because it's so thorough, and somebody independent is going to be checking it if you certify it. Now, at the plus level, you can see it could be a passive house plus, which means it could be a net zero energy building, this. And the difference between the classic and the plus is just the difference between a gas boiler and an air source heat pump. So they ended up with this, a gas boiler and some PV, and that's 1.1 tonnes of carbon a year. That's what that is emitting to run that house. But if you swap out the gas boiler with the air source, it drops to 0.2 tonnes. So that's, you know, the amount of carbon that the house is costing the environment is very, very different. Even though you've done all those things right, the same house will make a big difference according to its energy source. And that is the difference between classic and plus. The difference in cost, of course, is between, you know, a gas boiler at say 2K and an air source heat pump say at 8K. And the reason for the difference in the carbon is because the carbon intensity of gas is around 270 grams per unit of energy. Whereas you can see this blue line of electricity has plummeted over the last 7-8 years. And that's as we are beginning to decarbonise the grid. So you can see in the UK, we're actually doing quite well. It's a good news story. And you can see that towards 2050, I did that calculation based on 100 grams of carbon per unit of energy. And you can see towards 2050, that house will begin to use even less energy over time, whereas it will stay the same with gas. So this is why we encourage people to design their low carbon houses using electric energy. And here's the same house again, just showing this is the amount of carbon if you did gas and you used masonry to build it, and here's timber and electric. So it's the same standard, same energy demand, but the difference in carbon terms can be quite significant according to the other choices that you make. And there's the finished house. So yes, it's very good in terms of its operational carbon, and that's what the PHPP was doing. It's good, it's in terms of embodied carbon, and it's quite good actually. That was the cost of it, about £1,900 per square metre. Not so good in terms of its energy source. So lots of elements coming together in the end, much bigger than just passive house. So I'm coming to the end of my talk now. I'm just going to show you another couple of houses we've done. Really, the house itself can look as you like it. The difference will just be in cost. There's another one we've done with a very good, very inefficient shape, still a passive house, modelled using PHPP, a lot more expensive because the form factor is so poor. It's so spread out, spread-eagled with lots of different shapes. So you can do what you like. You can use the PHPP to model, but it will be a lot more expensive to do a shape like that. So I hope you found that interesting. I hope we're going to have some time left to do a few questions, and Katie's hopefully going to join us again.
Hi Jay, thank you very much. So yeah, we've got time for a few questions this morning. So thank you everyone for submitting them. We've had quite a few come in. So the first question, Jay, is, are there standard or accredited construction details available for the passive house to meet the thermal bridging requirements?
There's no such thing, as far as I know, as an approved robust detail. I think they do accredit a system, but I don't quite know how they do that, because it will. So my answer is sort of. But I'm not quite sure how, it's not really possible to do it robustly for every house, because every house comes with unique. So you could have a house that was pre-designed and that could be accredited because they could, but because every house has different structural challenges, you can't really have a complete tick box. But if you have you can have a system that has details, and they have like ours, where we've built numerous houses and they've been certified, so you know that those details have been used over time and adapted as needed be per project by project.
Okay.
That's slightly difficult, but each house is unique, is what I'm saying, I suppose.
Yeah.
So there's always some tweaks that you need to do.
Okay. Brilliant.
And you need to model a PHPP on every house. You can't get away without doing the PHPP on every house. I suppose that's what I need to say. You need to do the PHPP on every house, its location, its design.
Okay, thank you. And now for the second question, which follows on quite nicely, actually. Rob has asked, where do we find names of suitable companies or consultants who can undertake PHPP analysis?
I think the best place would be Passivhaus Trust, and look for members there, and maybe ask them for some recommended people. And then when you have I mean, obviously there are, you want to know that someone's done the PHPP course and is a certified designer or consultant. That's the first thing, to make sure they have done the course, the certified designer course. And then I would be asking them, how often do you do PHPP? You know, I would want somebody who was doing it fairly regularly, or somebody who said they were I don't know, somebody else was checking it. So if I've been doing one for somebody, a client, and they're doing it for the first time, but we're checking it, that's quite a good process. So they're learning and we're checking.
Brilliant, thank you. So I think the last question that we will answer today, it's from Will, and he's asked, is large open plan living possible with Passivhaus design?
Yes, it's very suited to it. There's nothing in the actual design. A Passivhaus can look anywhere you want it, and a lot of the houses that we've done, you would go in, you wouldn't even know it was a Passivhaus. It's very suited to large open plan. There's no reason at all. The heating solution, that Passivhaus is trying to get the whole of the house into a single heating zone. So it should all feel, yeah. So basically, yeah, it's fine. There's no problem with that at all. No problem with that at all. It's more of a structural issue if you're having huge spaces, how you span them. It's nothing to do with Passivhaus.
Okay, well, we do actually have a few more minutes left before we have to wrap up thinking about it. So I've got another question, if that's okay with you, Jay. So this one's from Derek and Sandra, and they've asked, is it worth purchasing the PHPP software as an individual self-builder?
If you're technically minded, I would say yes, and you've got that level of interest. You see, I've had one or two people I've worked with in the past who've gone on a PHPP course themselves, taken themselves off just because they're really interested. And even if someone else is doing your PHPP, it means you can play with it and look at it and interrogate it. So yes, I mean, if you've got the interest, it's not very expensive. Why not? The more interest you take and the more control over your own project, the better, in my opinion.
Zoe has asked us, what is the best way to teach yourself how to use the PHPP?
I think you would be best going on a course, and there are courses, they're just day courses. So you get an overview, and then I would actually get if you're planning, lots of people on this are planning to do their own house, I would get their own house and try and insert it yourself, you know, go about measuring and actually put it in and start, you know, inserting your own house in. So I think I would suggest you need a course, although it does come with a massively thick, I think I've got the thing here. It comes with this massive foot, look. But that's not very, you know, that is a bit much to be, you know, I would want to go on a course and actually have someone to talk to about it.
Brilliant. Okay then, well, we will leave that there then, I think. Apologies, we've had quite a few questions come through today, but we will have time in the final session at 3 o'clock to answer the rest of the questions that have come through. So I'd just like to say thank you to everyone who's joined us for the session today, and you will receive an email shortly which contains the link to watch back today's recording. Our next session is from 12 until 12:45, and this is a live guided tour of the NSBRC's Passivhaus exhibits and approved products, and that will be presented by Alan Budden from Eco Design Consultants. And just to let you know, this next session will take place as a Facebook Live session, so it's a slightly different format, so it won't take place as a webinar, as the first two have done. So in order to access this, you just need to head on to the NSBRC's Facebook page, and you'll be able to find the recording there. We look forward to seeing you there. So I hope you found it helpful. Thank you very much, Jay.
I hope you all found it helpful.
Yeah, had lots of comments come through saying everyone's found it quite helpful, so that's brilliant. Thank you very much, everyone. Look forward to seeing you at the next sessions. Bye.